Good morning children, we proceed on to exercise 9.4, some more problems on special limits. Limit x tends to 0, e power x minus 1 by x is 1. Limit x tends to 0, a power x minus 1 by x is log a. So let us do some problems on these two limit values. Exercise 9.4, question number 15. Limit x tends to 0, 2 power x minus 3 power x by x. As I recall the formula, I want a power x minus 1 to apply. So let us add and subtract 1. Combine these two terms. 2 power x minus 1, let me combine. And 3 power x 1, let me combine. Taking minus sign out, it is 3 power x plus if I take minus, it becomes minus 1. So as I add and subtract 1, I combine minus 1 with 2 power x plus 1 with 3 power x. Taking minus sign out, it becomes 3 power x minus 1 divided by x. To apply the formula exactly, first term by denominator, second term by denominator, we have split. Putting the limit for the first and for the second. Let us apply the formula. Instead of a, we have 2. So it becomes log a, that is log 2. This becomes log 3. Whenever there is minus symbol in logarithm, we write log of 2 divided by 3. Question number 16. Limit x tends to 0, 3 power x minus 1 by root of x plus 1 minus 1. Again we recall this formula I want by x. So let us divide by x in the numerator as well as denominator. The numerator I can put the limit separately, and for the denominator we have put the limit separately. Numerator, as I apply the formula, it reduces to log 3. The denominator, let us recall the formula learnt in the previous exercise. Limit x tends to a, x power n minus a power n by x minus a is n a power n minus 1. Root I can write power half. 1 also I can treat as 1 power half. Denominator there is x. But I want plus 1 and minus 1 to apply the formula. Add and subtract 1. Now it becomes x plus 1 minus 1. The numerator x plus 1 power half minus 1 power half. As we apply the formula, it is n a power n minus 1. I have n is half, a is 1. Half 1 power half minus 1. 1 power a number is 1. 1 into half is half. Reciprocate. 2 goes to the numerator. In logarithm, the number near will go to the power. So it is log 3 power 2. That is log 3 square becoming 9, and log 9 is the final limit. Question number 18. Limit x tends to infinity, x into 3 power 1 by x plus 1 minus cos 1 by x minus e power 1 by x. As I look at the problem, 3 terms are having 1 by x. Let us put 1 by x as y to apply easily. So 3 power y, 1 minus cos 1 by x is y minus e power y. Here x is there, 1 by x is y, so x will become 1 by y. As x is tending to infinity, 1 by infinity will become 0. So when x is tending to infinity, y will tend to 0. Applying all this in the given problem. Now, I want 3 power y minus 1. What is the formula that I remember? Limit x tends to 0. A power x minus 1 by x is log a. To apply, I need minus 1. So, 3 power y given in the question. I need minus 1. So subtract and add 1. This value we have given. Copy this one as it is, minus cos y minus e power y. Again, I have the formula limit x tending to 0, e power x minus 1 by x is 1. I have e power y. So to apply, again I need 1. So let me add and subtract 1. Now check in which way I can combine. I want 3 power y minus 1. I want 1 minus cos y. I want, if I take minus out, e power y minus 1. So this plus 1 and minus 1 is getting cancelled. As we join 3 different terms, let us split y for each. First term by y, second term by y, and third term by y. Let us recall this formula. Limit theta tends to 0, 1 minus cos theta by theta will become 0. As we apply the 3 different formula for the 3 different terms. First one, log a. Here it is log 3. Second one, the entire answer will become 0. Third one, e power x minus 1 by x becomes 1 as x tends to 0. So this particular term becomes 1. So my final answer is log 3 minus 1. Question number 25, limit x tends to 0. E power x minus e power minus x by sine x. We recall the formula e power x minus 1 by x becomes 1 as x tends to 0. So let us add and subtract 1. As I combine, I want e power x minus 1. So these two terms let me combine, taking minus out. It is e power minus x minus 1. First term is e power x minus 1. Denominator we have sin x. To apply the formula, I want by x. So every term let us divide by x. So this term by x, this term by x, also the denominator by x. If I divide every term by x in the numerator as well as denominator, my answer is not altered. Let us split the limit. Limit for the numerator, limit for the denominator. The numerator also there are 2 terms. So put the limit for the first, put the limit for the second. We know this formula fully. I can exactly compare, which becomes 1. To apply the same formula here, e power what should come in the denominator? E power minus x is coming. So I want minus x in the denominator. So let me multiply and divide by minus symbol. So I get this answer also 1. There is minus 1 into minus, so it becomes plus. Denominator, by applying this formula, it also becomes 1. So we are left with 1 plus 1, that is 2, and that is the final limit value. Question number 26, limit x tends to 0. E power ax minus e power bx by x. To apply the formula, e power x minus 1 by x is 1 as x tends to 0. I need to add and subtract 1. Combine e power ax minus 1 together and e power bx plus 1 together, taking minus symbol out, and as I divide by x. First term divide by x, second term divide by x. I know I can split the limit for the first, split the limit for the second. As we apply the formula, it is e power what should come in the denominator? I have e power ax. So what I do? I want ax in the denominator to apply the formula. Multiply by a and divide by a. For the second limit, here e power bx is coming. To apply the formula, I want bx in the denominator. So what I do? Multiply by b and divide by b. As we simplify, bring a out, this entire limit becomes 1. because as x tends to 0, ax tends to 0, bx also tends to 0. So I can apply here instead of x tending to 0, I can very well put ax tends to 0. So this full limit becomes 1. Similarly, b into this full limit becomes 1 just by this formula. A into 1 is A, B into 1 is B, and so we get A minus B as the final answer. Question number 19, limit x tends to infinity. X into log x plus A minus log x. When I say log in the problem, let me recall this formula. Limit x tends to 0, log 1 plus x by x gives rise to 1. In this problem, I have x tending to infinity. Can I apply the formula? Here I have x tending to 0. So naturally some substitution is needed. As I simplify this, log I have minus symbol. Minus symbol tells me to divide. Let me split x by x plus a by x. X by x is becoming 1 plus a by x. Now, this x in the numerator, let me bring down. I can bring down as 1 by x. So, everywhere I have this 1 by x term, put that 1 by x as y. When I put 1 by x as y, x tending to infinity tells me y will be 1 by infinity, that is 0. So, as x tends to infinity, y tends to 0. Putting all this back in the question. X tends to infinity, I write y tends to 0. 1 by y. X is 1 by y. Log 1 plus a, 1 by x is y. Now this reduces to this formula exactly. So I can put limit y tends to 0, 1 by y log of 1 plus ay. See, 1 plus what should come in the denominator. In my question, I have ay. So what should I do? I want ay in the denominator. But only y is there. So multiply and divide by a. So that this entire thing reduces to 1. What is left out? A. So a into this full limit value becomes 1 by applying this formula. A into 1 is A, and that is the final answer.